Welcome back. In this video, we are going to discuss about data pre-processing for data scientists. When you talk about data scientists, most of their times are spent on doing a data pre-processing. If you believe it or not, 60 to 70% of the work has spent for collecting the data, cleaning the data, organizing the data for analysis based on industry research. You can Google it and find out. Even if sometimes it's more than that. So when you talk about data scientists, first thing you need to have a data. Let's say if you are having a small application, further you need to think of it how you're going to collect this data, whether the user going to have an option to enter the data or the user have option to select the data. Then you once you collected all this data, you need to go through the cleaning process. That's what we can see that we have spent more time on data pre-processing activity. So you can see from where this data may problems may arise. Data problems. It can be from human when we are entering into the system or application or software. We have a high chance human errors can be possible, or maybe error in data transmission as we are dealing with lots of Wi-Fi, Bluetooth devices where it may have a problem with the data transmission. There may be error in data or maybe a problem with the hardware itself, or maybe problem in a software, a data inconsistent from different sources. So that this is the major part of it where the data related problems start to arise. As we are seeing a huge growth in modern technologies and robotics, think of it this particular video, how the robots are used for a pepper harvesting. So think of it, what kind of data related problem may arise when we use this modern technology. You can see here where these robots scan the fruits and check whether ripe for the picking or not. So it's going to collect data as well about individual plant and also individual each and every pepper that's going to be picking from this particular device. So think of it, what kind of data related problem may arise. So enter in the comment section so that we will see the different varieties of problem that can come from modern technologies like utilizing this kind of resources your use case. So data pre-processing, why it's matters. So when it comes to data pre-processing, first thing is all about handling the missing values. So identify, address missing data so that you can maintain some integrity and also improve the model accuracy. Why it's matter again? If you see when you talk about model, if your data is not clean, it's not going to be helpful in giving the accuracy or providing some kind of output that is reflecting on your revenue and also goes towards scaling and normalization, equalize feature influence so that you won't be having a bias towards something, so which will have a reliable analysis and also enhancing the data quality, clean and transform data for accurate analysis, which can go towards data integrity, removing the inconsistency, ensure data reliability by removing the errors, identifying the outliers, and also improving the algorithm performance where you can apply your machine learning or deep learning model to get a better result. So this is the main reason we need to focus more on data pre-processing. Applying a model maybe 20 to 30% only. The rest of is going to be doing a data pre-processing. Let's dive into it and see. When you talk about data pre-processing, we have four different key steps. We start with the data cleaning. So we start with the data cleaning. Then we have a data integration, data transformation, and lastly data reduction. We are going to see this one by one in a while. So where we have this data cleaning, data integration, data transformation, and data reduction. When you talk about any data set, sometimes you may need to do all these four steps, or maybe you need to do only one or two steps, depends on your data quality. If your data is good, then you just need to do only data integration or a little bit of data cleaning. But somehow you need to do all these activities in your data pre-processing. So when you talk about data cleaning, this involves filling any missing value. So if you have seen any data set from Kaggle, you would have to check for it whether any missing values are there, smoothing your noisy data, identifying or removing the outlier, and resolving the inconsistency to ensure a data quality. Next, if you look at some of the common issues specifically related to data cleaning, first thing I will say is missing values, handling the outlier, converting the data types. You can take an example of time. It can be use case where you will see different applications would have given a different data types for it. Standardizing capitalization. This is another important thing where people have a example. If you write a blue, this is different meaning, not different variable. This is different variable, and also all three different will be if you are using the case sensitive application. Removing the duplicates, removing the irrelevant data. These are the common issues that goes towards data cleaning. Let's see how we can address this. As I mentioned, some of the common issues are listed here. Age entries in data set. Sometimes people don't want to enter the age knowingly or unknowingly, they miss the field. So how we can do that? We can start with a simple imputation where you can fill the values with the mean, medium, mode, or maybe any other predictive modeling can be used to find the missing values in our data. And also handling the outlier. Example, if you are doing a house price prediction, you have a house price for one or two values only very, very high, or maybe very, very, very low. That may not be helpful in your model analysis. So that you can remove that, where you can use some kind of approach with robust statistical method to solve this kind of a problem. Remove extreme value beyond the threshold values. Converting data types, as I just mentioned in a previous slide, it can be represented in a string or may not be string. Supposed to be, it has to be converted to data type, where you can use the proper typecasting libraries to convert this. Standardization on capitalization or lowercase on the product name or particular field. So you can use this convert to consistent format with the example lowercase or uppercase. Duplicate customer records to identify and remove the identical rows. Irrelevant columns in a data set where remove unnecessary features. These are some of the common issues and how we can handle these issues. So let's move on to the next one, which is data integration. When you talk about data integration, this is one of the most important thing where you will have your data sets coming from multiple sources where we need to combine this. So when you see data scientists, those who are starting their project, they just go to Kaggle and take one single Excel file. I will recommend you to take an Excel file where you have more than one, and then you try to combine this, so where you will start to see all the problem arise related to that. Then you will be having a real hands-on experience related to data integration. Even you can see in our mobile application how many different sources. If we take an example of a smart home or smart city, if we take an example of smart home, we have a data from aircon, we have a data from TV, we have aircon from data from other smart devices that is there. So all this data need to be combined for your smart home application. So merging a multiple database, data cubes, or maybe data mart files to create a unified data set for your analysis. So common issues when it comes to data integration, data inconsistency. Each and every application may have their own different format that need to be fixed first. That goes towards data inconsistency. Next is data duplication. Look at the data quality, data security. When you are integrating from multiple applications, this is one of the important areas as a data scientist you can focus. So data security. Lastly, data governance. Looking at the policy, who is going to have access to this data, and how we are merging this data, what is the expiry on the data, when is the deletion. So there are a huge area to be covered on data governance that goes towards data stewardship. We don't go into that much detail, which is part of a data integration. So how we can address some of this. So example, as I said earlier, different date format across the database, standardize the data format across the sources, duplicate customer records. Maybe you can use some deduplication algorithm to remove the duplicates, errors and missing values in integrated data. So this is the place that we need to apply thorough data cleaning and data validation techniques. When I talk about data security, look at the unauthorized access to sensitive integrated data, where you can apply encryptions or access control or multi-factor authentications to make sure that you don't give access to everyone. And lastly, data governance. This is the place where you need to develop your policy related to managing the integrated data. So who is going to be have access to it? Develop a detailed or data governance framework policy. Now every governments and agencies are working on for data governance. So which is the more important now, developing the policy. Similarly, you can watch this video where a drone-based computer vision integrated technology collecting the data about cows and farm-related information. Think of it, there is a high chance for the data error, which will have a missing values and many other form of errors. So you can enlighten yourself with what type of error that may arise when we are looking at data from this kind of application. We can use the same concept for data integration as well. Imagine if you have multiple forms in different locations, so you want to integrate data from multiple form and then analyze that. That will be interesting to see the various data. So this could be the one of the area to be discussed, where we have modern technologies that are collecting the unique data that was not access to the this kind of data in olden days. So this data plays a significant role for data scientists to analyze. So moving on, the third element is the data transformation. So before we go to the data transformation, we have discussed so far what is data pre-processing, and then we discussed some fundamentals problem, the common problem in data cleaning. Then we have discussed about data integration. Now we are in a third one, which is data transformation. Data transformation techniques where you will apply normalization, aggregations to standardize your data and also provide some meaningful insights. Okay, some of the common issues that we will discuss here, where you see inconsistent data format, data cleaning and normalization, handling a categorical variables, and feature scaling, and also lastly a dimensionality reduction. So we have many more. I just selected only 5. So if you look at this issue, so where you have inconsistent data format, so when you combine even in the integration stage, we may face this problem, and also here we have this problem: CSV file, JSON file, Excel file, and also many other problems we have related to this data format. So that can be converted into all into one specific approach, which can be an Excel file, a CSV file, or a JSON file, depends on it. If you're working with the MongoDB, where it supports the JSON format. So you need to decide what kind of your mm, application that you're working on it. Raw data with error, missing values, or inconsistent. So especially if you are just collecting the data from any IoT devices, most of the time they start to arise. So where we need to apply filling missing values, removing the outliers, and also scaling features, and also handling the categorical data. So where you may need to convert into numerical format based on your algorithm selection. Example, you need to convert for a gender, or maybe convert for the city, or maybe you have options like a tall, short, where you need to convert that into number coding. So that's the place that where you will apply categorical data into a numerical form. Next, we have feature scaling. So this is the place where you start to look at a varying scale, which age and income. So where you can apply this normalization techniques. One of the commonly used normalization technique was min-max scaling, or you can use a Z-score or other method that is relevant to the data set that you have selected. So that goes towards the feature scaling. One of the important one, please pay attention when you are doing your practical, which is on the normalization. A dimensionality reduction, where you have a high dimensional data set with many features. I have a data set with 400 features. So are you going to use all these 400 features in your application for a machine learning model? So where you need to select the most commonly used technique, like you can apply a principal component analysis or a feature selection techniques to reduce the dimensionality so that your model can perform better on your accuracy. That goes towards the data transformation. Then last is the data reduction. So when you talk about data reductions, it's all about aim to obtain a condensed representation of the data set while maintaining the analytical integrity, so that reducing the computational computation as well. So that if you have a 1 petabyte of data, are you going to process 1 petabyte of data? It is going to take at least 1 or 2 days to process this. If you want to get a petabyte of data, you can go to this agency CERN, where you can be able to get a huge amount of data related to atomic physics. So where they are working on with the petabyte of data, they generate one day minimum of 1 petabyte of data. So we need to do some kind of a okay. Some of the common issues related to data reduction: loss of information, bias, overfitting, and interpretability, and also computational complexity when you are dealing with the data reduction. And let's see how we can handle this. So when you see some of the example reduction leading to a loss of critical insight. So if you want to reduce and select only a little bit of data, that may lose towards losing your most important thing. So you need to be careful when you are doing a data reductions. So come up with the proper evaluate trade-off between a reduction and data preservation. And also systematic error due to bias reductions, implement unbiased reduction methods, overfitting, fitting noise instead of genuine patterns. This can be an example. Use regulation techniques to prevent the overfitting. Interpretability, where you can difficulty in understanding a reduced data results. So this is the place you can utilize your visualization techniques, EDA, exploratory data analysis, to find out more information about this particular data, so that you will have a better meaning of the data set. Last is computational complexity, where excessive resource usage is reducing the large data sets. So optimize algorithm and employ some of the parallel processing, where you can go towards the distributed applications, so where you can use this approach. So these are the commonly used techniques for the data pre-processing as well. So to summarize, data science, when you talk about data science, pre-processing is one of the important area, and also it transform a raw data into insightful analytics. So you can start with the data cleaning, where you fix the missing values, address the noise data and outlier, go towards the data integration. This is one of the common area where we need to integrate your data from. You can take an example of social media. So you can take an example commonly used platform like Facebook, Instagram, TikTok. All these data need to be integrated if you are running a business, so that you can get a better insight about your customers. And also data transformations, where you apply this normalization most of the time. We have min max, z score, and other methods that we can use it. Data reductions, again, in the data reduction, that's another interesting area example. If you have 1 million users, so instead of asking them to give the individual street address, you can ask them for a city, or you can ask for the state, or even you can ask for the country. So we can reduce the data on it. I can give you another example for data reduction. Let's say if you have 100 store, you have 100 branch. Okay, in this 100 branch, you have everyday transaction, you have everyday profit. So you have everyday profit. Instead of calculating for day by day, you can combine that for a month. Then again, still, if you have 100, you have do it for a month, it's going to be a lot. Then you can combine them for the quarter, first quarter, second quarter, third quarter, and fourth quarter for each store. That's how you can do a data reductions, or maybe even you can do it for every year. So that's how you can do a data reduction. Hope you learned the fundamentals of data pre-processing here for data scientists. Thank you for watching.